Welcome to this quick start video with NRG. In the course of the next 15 minutes or so, you will learn everything there is to know about the NRGeditor, the workflow to use while creating games and 3D application with NRG. To get us started, let's head over to Blender. And in Blender, I am having this basic scene here that is going to be the base of a 3D platformer. A simple capsule and a platform. Take note that both of these objects use a principal BSDF, and we are going to use the default PBR shader generated from the NRG importer to get us started. So let's select the pill, let's select the platform, and head over to File, Export, and glTF. And I'm going to place this file on my desktop. Ensure that the transform Y up is unchecked since the Z axis is the up axis in the NRGeditor. Let's export and back to my NRGeditor. Using the project manager, let's select the project tab and go under new project using a default template. Specify that the project path is at a convenient location. In this case, I'm going to place it on my desktop. Create the project. At first, we have a blank screen, and in the background, we have already a scene, a camera, and a script to clear that screen that have been created for us. Below, we have the library. The library will act just like a file explorer where asset groups are actually folder and individual assets are file. We can see here that we have our untitled scene that is currently loaded inside of our View3d. The next step is to bring those assets and objects that we had in Blender onto the current scene loaded in my View3d. To do that, simply select the library and either use the file explorer of your current operating system to drag and drop that GLB file that we have just exported, or you can use the embedded file explorer of the NRGeditor. To do that, simply click on the asset menu and then import and go fetch that GLB file. Open it up, leave the importer settings to default and import the scene. We now have our object and platform that have been appended. Every time you import a new glTF file, in example, it will append the object or assets to your current library or scene if a scene is loaded. As we can see here under the library, we got a bunch of folder asset groups that have been created for us automatically by the importer. We got one for material, meshes, shaders, and texture. The next step will be to create another platform for our base 3D platformer. So our capsule, our pill, can fall on that platform, run over, and then jump to the next. We have multiple ways of doing this, but first of all, we need to be able to edit that current scene. The View3d is acting both like an editor and a viewer for the application. So we need to be able to toggle between edit mode and the final result of your application. To do that, you can head over to the render field of the View3d, and you will have here, as you expand this list here, all the render layer that are currently connected to your scene. Think of a render layer as a pipeline where same or similar object of a specific type are all placed on that render layer. So you will end up having in practice a render layer for opaque object and another one for transparent object. And the result of this opaque and transparent render layer will end up being the final image of your application. In this case, we only have one, so I'm going to select it. And now my View3d is in edit mode. Using my right click mouse button, I can navigate using WASD. I can select object around using my left mouse button and drag my view with the right mouse button. So we need to create another platform. We have multiple options to do that. Let's go over the first one. That will be to interact with the library and place and recreate manually another platform. So I'm going to go under meshes and I'm simply going to drag and drop my platform in my View3d while being in edit mode, and a new platform has been created. I can repeat the same process to connect a material to it by drag and dropping the platform material onto that newly created object. I can use the manipulator to move it around, and I can rotate it if I want to, or scale it. For the next method, with my object selected, for the next method, I am simply going to create a duplicate of that object. So select the object that you want to duplicate, object, and then duplicate. Head over to the outliner. The outliner is a 2D flat representation of your scene, and we can see that now we have two platforms. This is the copy, the duplicate that I just created. This 2D flat representation of your scene allows you to also select objects and toggle default state for each and every object, and also you can reorder the rendering sequence of your object. Since we're doing a 3D platformer and we're going to use a depth buffer, we will not see a real impact of reordering these objects. But if you were, in example, creating a graphical user interface, the order that the objects are actually rendered on screen will have drastic impact over the final application image for that particular scene. So let's head over and select that platform and try again to move it in space. And as I move the translate manipulator, nothing happened. And the reason why nothing happened is because this specific object at import time did not have any physics settings applied, any keyframe animation or bone animation applied. So the importer analyzed that this object is static, and to toggle off that static state, we can simply click the pin here. So since most of your scene, 90% of the object of your scene will be static, it is highly recommended to leave that pin on for each object that will not move. Like that, the transformation will be calculated only once and then reuse over an infinite amount of frame. With my newly created platform on pin, I'm going to now be able to use the translate manipulator to move it around. And instead of using the rotate manipulator to rotate the z-axis 180 degrees, I am going to access the properties of that object. So under the properties tab, we are having the default properties for the persistent subsystems, such as the application, the sound, and our physics world, the scene that we're currently editing loaded in the View3d, and object-specific properties here that I'm going to access by clicking the object. And we can see here that I am having my rotation. I'm going to switch the rotation mode to be Euler, and I'm going to manually add 180 degrees to rotate my platform. Using the translate manipulator, I am going to slightly adjust it to ensure that my capsule can jump over properly. And this is all set. Back to my outliner, I am going to pin it back as a static object. In this scene, only the capsule itself will have to be dynamic. So I am going to unpin it, and I am now ready to add physics and user interaction. So I am going to select my capsule here, and with my capsule selected, properties, and then physics. I am going to add a rigid body so it can interact in space and fall off, pulled by the gravity. And I'm going to need to add a collider. What is the most basic shape that can represent that capsule? And luckily enough, we got a capsule. Later on, you will be able to replace that pill here with an actual animated character. But for now, let's select simply capsule, settings, and do a bit of tweaking here to have this capsule collider shape as tight as possible as our original capsule. I'm going to use my right mouse button and drag to change the radius here. Let's say that we have a 0.5. That should be tight enough. And now I'm going to have a first test run at my 3D platformer. I am going to go under File and Save and hit the play button that simulates my application. As I push play, we can see that our pill fall into oblivion. This is because we need to have also static physics that it's applied on our platform so we can have a floor. Let's select the platform, similar process, properties and physics, add physics, static physics, and what is the collider that we will be using? A simple box to keep things relatively easy. Same thing for my other platform, static physics, add a collider, and box. This time around, instead of using File and Save Project, I am simply going to hold the Shift button and click the play button so it will automatically save before starting my application. And now we can see that the pill fall off, but something is not right, it banked on the side here. That is because we're using a rigid body that responds to linear and angular velocity. We need to be able to disable that angular velocity to ensure that our pill is going to stay straight up. Let's push stop, select the capsule, and drag under with the physics tab selected, drag up a bit and go find angular factor. And we're going to set all the angular factor down to 0. Instead of going back and forth and saving file, save, or shift and play, what we can do, we can pop a timeline editor that is going to control the application time but does not put us in our game. So we are going to go and open a timeline editor, and at the bottom of the timeline we got this little button here that is the same as the physics. So I can use the play button that are located either in the View3d or down below here in the timeline itself to increase the application time, have my physics running, and like that I can make adjustments straight in the View3d in my scene that I'm editing here. So I am going to toggle it on and I am going to push play, and we can see now that our capsule fall off and it doesn't bank over. The next step is going to be to add interaction, to have the user touch keys on the keyboard and move that capsule in space. So for that, we're going to need to add script. Every interaction comes from a script. So with my library selected, I am going to go under Asset and then create a new script that I'm going to call Controller, and select that I want to have a basic template for the onUpdate function that will be created for me. OnUpdate will happen once per frame per object. So I am going to click the Create button, and now I have my script. I can, to connect this script to my object, either select the object property and add a new scripting slot, drag and drop my controller, and we can see that it's going to now respond to the onUpdate event. Or alternatively, I can remove that and simply drag and drop my controller script on my capsule here, and it would automatically create a scripting slot for me. I actually create that script into the material asset group, and I'm going to drag and drop it back to my root here. As you can see, the library is exactly like a file explorer. You can drag assets around or asset group around as you please. So my controller is now at my root of my application and connected to my capsule. Now I actually need to add some code in order to detect that the, in example, D key on my keyboard, lower D, have been pressed to move my capsule around. To do that, I'm going to need to edit that code. So clicking at the edge of any of the editor will pop the list of all possible editor available in the NRG editor, and I'm going to click on code, select my controller, and on my update function, I need to get a feedback that this object actually call this function. So I'm going to use the keyword this that I'm going to print on the console here, and if I build, we can see that now we got our object user data that keep calling this update function each and every frame. What I need to do is to add code to detect my key press. So I'm going to need to have two variables, one for the physics object itself and another one for the rigid body. So I'm going to create a local variable that I'm going to call PBO for short for physics object, this dot physics object. And now I have in PBO a direct reference to my physics object. I'm going to repeat the same process for my rigid body, RBND equal to this time PBO dot rigid body. And what I want to do is to access the linear velocity of my physics object and increase it when I push D moving right and decrease it when I push A moving left. So what I'm going to do, if with my code editor selected, if my application get the state of a specific key, which in this case will be 100 for D, dot press, if this key is pressed, then what we're going to do, Rigidbody RBD dot linear velocity, the linear velocity property dot X, since everything is happening on the X axis here, the red one, equal to the linear velocity plus, let's say, small value 0.1. I am going to build and go back to my viewport. And now to send input directly to this viewport here, I am going to select application. With my viewport selected, if I push D, we see that our pill start moving and as it fall off into oblivion as it reached the end of the platform. Let's fix that right away and make sure that the pill will come back to its original position. If we go back to our edit mode, with our object selected under the physics property, because right now our application is running, we need to bring it back to its original state. So I'm going to hit here the reset transform, and as you can see, my capsule go back in position. And I'm going to reuse that API. By observing what's on the console, I can see that the physics object reset transform function have been called. And this is exactly the API that I'm going to use if the linear Z, because the Z is up, if the linear Z velocity is going below a specific threshold, simply call that function. I am going to copy in my clipboard the reset transform, head back to my code, and this time around I'm going to code if my RBD dot linear velocity dot Z is below, let's say, -20, then my physics object PBO and call the reset transform function. Let's build that again. Linear velocity. Let's build that again. Select application to gather the input. Ensure that my pill fall into oblivion, and as it reach -20, get back straight into position. Now let's code to go backward, back in the code, copy this block here to analyze the key A, which is going to be the ASCII 97, lower A 97, and this time around simply minus the linear X velocity. Build, back to my View3d, back and forth, now run properly, but I seems to be keep accelerating as I hold the button. I don't really want that, so I'm going to clamp that linear velocity, and to do that I'm going to call the clamp mat function, linear velocity X equal to mat clamp, a float value, my linear velocity, and I want to make sure that it goes in the range of, let's say, -2.5 to 2.5. Build again, and let's test. We can see that now the acceleration of our capsule is a lot more stable. One last thing remains is to make that capsule jump. So we already analyzed that if the linear velocity Z is going negative, we're going down. So what we want to do to jump is to put it up for a little split second to be positive. So to do that, same code as we did earlier. Copy this block here. Let's add it below. And analyze if 32, the ASCII 32, which is equivalent to the space bar. This time around, Rigidbody linear velocity Z is equal to Rigidbody linear velocity Z plus, let's say, 0.5, and I'm going to build. As I go back to my View3d and I push space bar, we can see that now our pill is floating in the air. If you're looking for creating an application like the famous Flappy bird, you already got all the code necessary to do so. But since we're doing a 3D platformer, what we want to know is, does this capsule actually touch the ground? And to do that, I am going to need to have access to the contact information of my capsule with the platform. If I switch temporarily the shading to be wireframe and head over to my world properties and scroll all the way down using Shift and the right mouse button, under physics bounds, I have an option to display the contact point. And as I do that, you can see that we have an orange line here that is now visible. This is the actual contact point. We got a point here, and the line here is the normal of that contact point. So I need to create a small function that is going to analyze if my contact point normal Z is pointing up, and if it does, it means that I am currently on the ground, and then I can allow the player to jump. I'm going to disable that, go back to shaded, to my code, and I am going to create a new function that I'm going to call onGround, and this function will take in parameter a physics object, PBO. Now I'm going to need to iterate through all the contact point of that specific physics object. For I equals 0, my physics object get contact count, how many contact point this specific object have, do, and then end. If the absolute value of my normal Z, math.abs for absolute, physics object get my contact at the index dot normal Z, and let's say if it's greater than 0.85, which is basically straight up, then my function will return true. If no contact point or no contact point that contain a normal Z that is greater than 0.85, return false. I'm going to copy that in my clipboard and add it to my condition as when my spacebar is pressed. So first, if I'm on the ground and the spacebar is pressed, then I can safely say that I can jump up. I am going to build and save. Back to my viewport, select application so my viewport can receive user input, select it, and now as I move around and press the spacebar, I can now jump properly. Using the same process and code base that you have learned during this video, 2 more advanced tutorials are available on our website. One for more intermediate developers, which is entitled MicroLand and contains a series of step-by-step online video tutorial showing you how to recreate it from scratch. You will learn how to integrate an animated character, build an action controller, discover how to create collectibles using ghost physics, handle kinematic platforms, and dive into how to handle a customized complex rendering pipeline. It is available at nrgcore.com/micro/land. Initially created for the Kenny Game Jam, this next tutorial is for expert users. It contains a summary of the 2 previous tutorials and add additional paradigm where you'll learn how to deal with baddies and implement artificial intelligence, traps, features a fully customized rendering pipeline, and more. You can access the demo page from this URL, nrgcore.com/demo/pp. Take note that both tutorials come with the full source code and all assets for all registered users. Grab your own copy of these projects and start learning how to build your dream game using NRG today.